IGP number 17 for the fluids chapter. We are trying to set up that the velocity coming out of a Torricelli scenario is equal to the square root of 2gh divided by 1 minus a1 squared over a2 squared, where if this is our tower and this is the hole in it with the water kicking out, we're calling this V1 and everything over here the 1 scenario and everything relating the top going down as being the 2 scenario. In this problem though, we are not assuming that the top is stationary. We're assuming that the top is moving down with some initial velocity v2. So this problem gets a little interesting here in trying to set up. This is the final answer we're trying to prove. So that's what we're going for here. Okay, so let's try to do this. Let's start with big old Bernoulli, right? So we're gonna do this. P1 plus 1/2 rho V1 squared plus rho G H1 equals P2 plus 1/2 rho V2 squared plus rho G H2. Okay. A few things we can do. Pressure pushing here is the pressure pushing here. So those subtract out. Okay, that's nice. We know that this is actually a delta H in here. So we know that we're going to get all of our densities to divide out. Whew. Now we don't have the density problem. That's nice. We know the G, H1, and H2 are going to become the delta H. So that's nice there. So let's just combo those together real quick. Where do we want to toss them? Let's toss this over here. So if we do that, and we just kind of clean this up a bit, we just did a bunch of math on the fly. We've got 1/2 V1 squared equals 1/2 V2 squared. And then, oh, you know what? It might be actually a little bit easier to tag this over. I think that's going to be easier there. Yeah, let's do that. Plus rho, oops, we got rid of the rows, plus G delta H equals 1/2 V2 squared. Okay, so that cleaned that up a little bit. Oh, you know what? No, we want the V1s. Cheese and crackers. Cheese and crackers. It's one of those days, right? You do a billion of these and you start going insane. We want that over there. We want V1 by itself. We want V1 by itself. So this is going to be 1/2 V2 squared plus G delta H. There we go, because that's 2 minus 1 then. Huh. And there we go. Okay. So if we get rid of our half out here, we multiply everything by 2. The 2 does that. There's our 2GH. So we're getting closer. There's 2GH right there. So we're getting closer to our answer, which is right here. That's what we want. Let's see. We run into a bit of a sticking point, though. In our answer, what we're looking for, there's no V2. We need to get a V2 out of there, and we can do that. We know by the mass continuity principle that A1 V1 equals A2 V2. And this means that if we solve for V2 here, so we can substitute, what we have is A1 V1 over A2 equals V2. And what this allows us to do is it takes this number, this quantity, and plugs it in here. And this is also nice because this answer has A1 over A2s in it, which is what we're looking for. So if we rewrite this now, what we're going to have is V1 squared equals A1 V1 over A2 quantity squared, which actually means that this squared value goes to all of these, plus 2G delta H. So I'm going to kind of rewrite that out for completeness. V1 squared equals A1 squared V1 squared over A2 squared plus 2G delta H. What I can do now is I see that these V1s are like terms. So what I'm going to do is I'm going to subtract all of this over to my other side. So what I'm going to have then is V1 squared minus A1 squared V1 squared over A2 squared equals 2G delta H. And the reason I'm doing that is now I see that this V1 squared is a like term here. So I can pull it out. I can have V1 squared times the quantity 1 minus A1 squared over A2 squared. And that's that quantity I was looking for up here. I was looking for this quantity, this 1 minus A1 squared minus over A2 squared. And this has to equal 2G delta H. And I'm feeling good about this now. I feel that we're just a step or two away from finishing this out. If I divide each side by the 1 minus A1 squared over A2 squared, those will wipe, and I'll get that quantity over here. So just to rewrite that, I have V1 squared equals 2G delta H over 1 minus A1 squared over A2 squared. And then if I want to get rid of that square root, I'll just root both sides. And then hey, look at that. That's what we were looking for this whole time. This goes to show that while normally for Torricelli's equation, we use Bernoulli and we assume that that initial velocity is 0, if that initial velocity had some value that we cared about, or if we were looking at, you know, what is this ratio difference between A1 and A2, you know, if I made the hole bigger in the bottom, something like that, how would that velocity change? And just by using big old Bernoulli and a mass continuity equation and doing a ton of algebra and just working it down, we can get an actual more clear solution to Torricelli's equation using Bernoulli's equation to see, you know, how do those ratios of the hole up top to the hole to the bottom actually affect us there. So that's intergalactic problem number 17 from the chapter 10 fluids unit. And with that, we're done with it. Just some algebra, big old Bernoulli, and working it out. Finn, take it easy.